Good morning and welcome back to Dr. Logic Awkwardly Does Logic. We've had a bunch of definitions lately, so I'd like in this video to just go through a couple of examples to kind of bring together all of the abstract theoretical stuff and show exactly how these sorts of things work. So if we've got our whiteboard, then we can get ourselves some diagrams representing Kripke frames. So each dot is a possible world. Each arrow represents a relation of accessibility from one world to another world. So let's just fill in a bit more. So we've got something moderately interesting. Let's bring this one over here. So from the point of view of this world, which we'll call W, two worlds are accessible, X and Y. So these are the worlds that W thinks are relevant for determining possibility. From the point of view of Y, we have V and U thinks that, well, let's call this W prime, W2 prime, because eventually we run out of letters. We always run out of letters. X also thinks that V is a relevant possibility, so it shares kind of a possibility space with Y, but it also, let's make that interesting, sees this world up here. Let's call this one X prime and this one X double prime. So here's an example frame. It just kind of lays out the possibility space and the way these possibilities are related to each other. We can turn this into a model by annotating each of the worlds with the atoms that are true. So I'm going to do this by noting the truth values explicitly. So P is true at W. It is false at X. It is false at X prime. It's going to be true at Y, and true at V, and true at X prime. And then it's going to be false at U, false at W prime, but true at W2 prime. So this is just a random made up valuation that I came up with. Now we can ask ourselves, what else has to be true? So we know that if P is true at W, not P is false. This is just a propositional fact. We also know that either P or not P is going to be true. And in fact, this will be true at any of the worlds. But let's think about the modal things. Modality is quantificational in the sense that in order to determine which values necessary P and possibly have at this particular world, we have to spread our attention out from this world to the things that this world can see. So P is necessary if every world that W sees makes P true. W can see two worlds. It can see X and it can see Y. Note crucially that because I haven't drawn an arrow like this, it doesn't see itself. So it doesn't consider itself possible for whatever reason. So we're just looking at X and Y, and it's not the case that all of these make P true because X makes P false. So this means we know that P is not necessary at W. However, because it can see Y and Y makes P true, it is possible because possibility requires that there only be at least one. Let's take a look at V. What do we have here for necessary P? It's again going to be false because V can see X prime and P is false there. And then it's still going to be possible because V can see X2 prime and P is true there. So let's squeeze in a possibly P being true. And in fact, there isn't any place in this entire model where P is necessary because every world can see at least one world where it is false. So X can see X prime and it's false. V can see X2, V can also see X prime. Y can see U, which makes it false. U can see W prime, which makes it false. But, what about here, 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 and here? What happens to necessity here? All of these are what are called dead ends. So they don't see anything. So if we want to ask ourselves, is it true that every world that each of these worlds can see, is P true at those worlds? Or another way of thinking about necessity is, can I find a world that makes that shows that the formula is not necessary? So if I want to know, is necessary P true, I have to ask myself, can I find a world where P is false? And that makes it very easy to see that at a dead end, necessary P is going to be true at each of these. So all of the other worlds all see a world where P is false, but these 4 worlds don't. So at the very end of our model, we do have a bunch of necessities. Not only is P going to be necessary at all of these, not P is also going to be necessary. And this is again because none of these worlds see a world that makes P true. So there is no way that you could falsify the necessity of not P. So this is an interesting fact about dead ends. And in fact, in another video, we'll probably go through a formal proof to show that this works for any formula whatsoever when you have a dead end. Everything is necessary. Interestingly, the kind of converse of this is that nothing is possible. And this is perhaps easier to see. If you are sitting in the dark with your eyes closed and your hands over your ears and you're saying, la, 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 I'm not listening to you, well, you're not going to have any input that would allow you to say, oh, well, maybe this is possibly true. You just have no information. And that's essentially what these dead ends are like. You just, you ask, well, is this possible? Is that possible? And the person in a dead end world just kind of throws up their hands. I don't know anything. I can't make any discriminations about what is true and what is false. And therefore, I cannot make any discriminations about what's possible and impossible. And this is because even though necessity and possibility are not truth functional in the sense that you just need to know the truth of the subformulas in order to determine the truth or falsity of the complex formula, it is still defined in terms of truth. And so you need to have access to this information. You need to be able to see what is going on at various worlds in order to be able to say anything useful about the truth or falsity of modal formulas. So here's an example. I hope that was useful. We will see many other examples as things come, but I'll try to interleave them in with kind of formal definitions and proofs so that at each step along the way, you can see how all the bits fit together. So join me next time for more definitions and more bits. We've got a whole bunch of building blocks that we need before we get to the really cool stuff. Take care and see you then. Cheers.